Alright guys, welcome to part 2 of Lab assignment 4. So continuing on to the section that's part 2, we're going to twist a cube. And this will familiarize you a little bit with some of the surface editing commands, or surface creation commands actually. So you'll see here I basically have that sort of same 10 by 10 sort of square grid, except the sort of top portion, I'm rotating it 30 degrees. So to kind of do that, what you want to do is basically take this, and you saw how to do this earlier, it's really simple. And let's move it up first by copying, so holding down the Alt key while clicking on the blue arrow by 10. And then basically clicking on this sort of blue arc, clicking right there, and then putting in 30 degrees, which basically gives us the rotation. Okay, so that's really simple, and you should be able to kind of use that to trace out this simple framework, and you can try it on your own. Okay, so the first example we're going to do here is still the surface point, and just kind of observe like how it changes. So this guy, the surface point, and you have to go in that specific order, or you would want to go in that specific order. But what you'll see is that even though like the points don't align, it basically creates a doubly curved surface that spans between the lines, so it twists for you. Okay, and so let's do the next one here. 2, 3, 4. Okay, so copy that to the next group set, and let's keep on closing out basically the sort of entire twisted cube. And as long as I'm sort of moving in one direction, as long as you're not crossing the points, they should close out like that. Okay, so now you have basically a twisted box like this, and what you want to do is to basically kind of get a good angle of it. It might be a little bit difficult, right, but try to get a good angle over it, deselect that, or just like pick 1, 2, 3, 4, right, which actually might be faster. Okay, join these guys, right, so you can actually join them together. Copy them out and cap it. Okay, that gives you a sort of twisted undulating cube. All right, so that's if you sort of construct it out of the sort of 4 points or 3 point or the surface point tool, it will do this. All right, now next one, it's actually really simple. Loft and then cap. So I'm going to go to the sort of second step here. That's the first. So I'll just pick these two, loft them, and make sure that they're in the same relative corner and they're going in the same direction. And make sure to look at the preview, look at it and see if it's okay, and say okay. So that actually was a lot faster than those steps, right? So we can essentially copy that over and just cap that. Same thing, more or less. Okay, the sweep one command. This command is actually kind of show you how there are some certain commands, and you might have experience to find that out. There are some certain commands that actually care where you click on when you're selecting things. So to kind of give you an example, the sweep one command, select a rail, you'll see that there's going to be a difference depending on when I'm picking this rail, where I click on the rail. So I'm assuming, so you see the sort of section I'm going to use is on this corner, right? So let's use that as a sort of boundary point. So if I click on this side of the boundary point, like somewhere closer to here, okay, and then select the cross-section curve and enter, you'll get this result. Okay, it uses a sort of wider angle. Now, if I do the same command with the same input geometry, but when I'm selecting the rail, I don't click here, but I click on there, right, which is sort of towards the end of this polyline, and we do the same thing, you'll get a completely different result. Okay, so this is one of those commands where actually, when you're selecting the sort of input geometry, where you click on in the line will actually make a difference as far as what you get as an end result. Because in this one, it will kind of use the wider sort of edge of this profile to kind of revolve it around. And in this one, because your input was actually selected there, so it actually uses the sort of inwards cut of it, of the profile, to kind of make the sweep, if you will. Okay, so this is a sort of tricky situation that you just want to be mindful of. Sometimes we're not getting quite the results that you're looking for. Okay, all right. Now, as we can see, because sweep 1 only uses one of these two rails to kind of create the sweep object or the sort of sweep geometry, it does this, which is not necessarily ideal. So the next command is the sweep 2. So sweep 2. So the sweep 2, as its name implies, basically looks for two rails instead of just one. So in this case, what your inputs are: first rail, which is this bottom guy, and then second rail, which is the top guy, and then cross-section curves, which is this. Enter, and you'll get this dialog box here that can, you can kind of change things around, whatever. Just say OK, and you'll get what essentially is similar to the sort of loft, right? Copy it over and cap it. Okay, that's the same sort of thing. Now, the big sort of difference, though, in terms of the sweep commands, is that it can actually accommodate, for example, different profiles. So I'm just sort of showing you, and you don't have to do this. I'm just showing you a kind of more extreme example of what the sweep 2 kind of can do. So besides the sort of straight line in the corner, both of these profiles are basically curved, right? But because the sweep 2 command can accommodate both the first and the second rail, but also essentially multiple cross-section curves, and basically create a form that conforms to that as best as it can. And sometimes it'll end like this, it doesn't know what to do, so to kind of close that off, I'll just use the loft command. Okay, so you're able to actually kind of specify even more precisely something like that. And obviously this you can cap as well. Weird, twisty sort of shape. Okay, you don't have to do that, but that's just kind of show you how sweep 2 is a little bit more versatile. Okay, next. This is a little bit of a different type of a command. It's basically centered around the twist command, but you'll see why we need to do this first. So let's make a box. Go back to good old box command, right? Corner to corner, and then give it a height. Okay, so that's the box. And I'll just sort of move it to the sort of second step. Okay, so while you select have the box highlighted, run the area centroid command, which is the second one. And what that does is that it I'll turn on actually ghosted mode so you can see. What that does is it actually creates a point at the area centroid of the volume, right? So it does calculations. It says, okay, this is basically the center of mass of this. Okay, and it's actually pretty good for calculating things like that. So for example, let's say this, right? this sort of donut shaped thing, its area centroid is obviously in that center over there. So area centroid, you'd get this, right, which is basically at the center point of this sort of mass, right? If you have something that's non-symmetrical, then it would actually give you what would more or less be the sort of center of mass of that volume as well. Let's just copy this over to the next step. Okay. So what I want to do is actually copy this point up and down, both there and there. So what I do here in this sort of scenario, there's already sort of one there. So copy, C, copy, vertical, turn vertical on. Okay, so C spacebar V spacebar is usually what I do. It's just the fastest. Click on this, and you go into the sort of elevator mode, right, which forces your copy to in the vertical direction, in the Z direction. And I snap to one of these corners, 1 and 2, and spacebar. So you'll see that I've gone basically the sort of projection of those points, right, on the sort of top and bottom faces, the projection of the area centroid on the top and bottom faces. Now this is one way to do it. You could also kind of do the old draw a line, find its midpoint, or cross these two lines, find the intersection. That's basically what we're trying to get here. Okay, we're trying to find the center of that face, right? So now we want to, this is just for visualization purposes, but I'll draw a line, and this is basically the sort of central axis of this cube. Okay, now we want to use the twist command and select objects to twist. This, enter when done, enter. Start of the twist axis, so you go from the bottom and you sort of snap to the sort of bottom end of this twist axis. End of twist axis, which is the top. Okay, and you can play around with this a little bit, but basically what it does is that it allows you to pick a first sort of beginning angle if you close it, and then you can do that, like an ice cream swirl cone, whatever, right? And obviously if you kind of do a sort of more exaggerated swirl or turn, then you'll get something that looks like this. Oh. Okay, so this is sort of more ice cream swirl than it is cube, but just to kind of replicate what we had before, right? Remember the sort of rotation was 30 degrees, right? So twist, select objects, enter, twist axis from here to here, same thing. And then here, instead of clicking, you can just enter the angle, which is 30. Okay, now what's the difference? As you can see here, if I look at what we had before earlier, okay, even though the sort of endpoints of the geometry are more or less identical, I can copy it over and just put it on one on top of each other, right? So you'll see that in this case, at least, this is actually, it has this sort of resistance to it, right? It's not these, it's the sort of twist version has this sort of resistance to it that's not the straight line. So it's a sort of slightly different method, and you'll see the results kind of as something quite different. Okay, so just so you recognize that difference between this and that, for example. Okay, this is just for fun. All right, next, the plane, and then extruding with a direction. So let's create a plane. Go to old rectangular plane, like that. Okay, copy it over, and then extrude with a direction. So extrude, extrude surface, so this surface, right, enter. Now usually the direction is vertical, right? This is sort of what you're kind of used to, but let's actually play with this a little bit. Now, there are a lot of options with extrude, and you'll sort of get used to this. The ones that you know probably is solid, but whether or not it automatically caps on the top and the bottom. Both sides, which actually makes it extrude both sides, like that. But let's play with direction. So I can actually set a arbitrary extrusion direction. It's something that's non-vertical, okay? So I just need to give it a base point. So let's say, using what we have here, right? What we already have specified. Let's just go from here, and this is basically giving it an extrusion vector. So here to here, and you'll see that it basically is extruding on an angle, right? And the sort of snap actually forces you to do actually snaps it to different things, and you can sort of play with really how far this wants to extrude. But let's just snap to that point. You'll see that there's a gap in the height, because the sort of extrusion is actually also calculating the sort of edge lengths. Right? So it's a little bit different. But basically this shows that actually you can extrude along a specific arbitrary vector that you specify, or a direction that you specify. Okay, now the next one is its counterpart, extrude surface along curve. Okay, so same thing. Let's make a plane here. Copy. So just type extrude, and you'll find extrude surface along curve right here. All right. Now in this case, we have the guide curve already there. So let's select this surface. Press enter when done. Select path curve near start, where you expect the sort of extrusion to start, and actually turn on the solid. Okay. And you'll see sometimes there are options to delete the import or not. So let's be careful and click sort of near the beginning of there, and you'll see this is what you get. Okay, so this is actually similar to that, but actually because you're extruding along a very specified curve, it gives you better control. It's not just like a generic direction, but it's actually a curve that will follow all the way through to the end. Now the obvious sort of connotation of this is if I edit this path curve and just like I did earlier, let's play around with that, right? To kind of change it. So copy this over, and you don't have to do this. I'm just sort of showing you. Extrude curve, surface along curve. The sky, enter path curve near start. See, this is basically what you'll get, right? So it will the sort of extrusion will actually duplicate the curve that you give it. Cool. All right, next one, loft. Well, you might say, well, we did the loft earlier here, right? Isn't it somewhere here, right? It's the same thing. Well, actually, no, this one is a little bit different. So this one, you'll see, basically, I've connected the lines here, right? One by one. So let's actually run the loft command first. And just kind of observe the sort of difference in the behavior, right? So if I run the loft command first, the sequence in which you pick your lines actually makes a difference. So if I pick 1, 2, 3, 4, spacebar, and you'll see actually some of these got flipped, right? So remember, I have to go to align curves, and maybe you have to flip 2 of them. So maybe the end, the two on the end, right? So you get this. Enter and say OK. Right? That's what that does. What happens if we pre-select and then loft? Okay, that does it automatically, right? Now you'll find that the loft actually sometimes will basically try to determine to the best of its ability what you're trying to do. Now this is more or less identical, so I'll just remove that. Now, if I run the loft command and I intentionally sort of pick these out of order, so I go, let's say 1, 2, 3, 4, you'll see it do this really weird thing where it's actually trying to follow your orders, right? And you'll get a really sort of weird, funky intersection. So when you mask select, when you select beforehand like this, like we did in this case, the loft command will try to order it, in a specific sort of way, or in a way that it thinks makes the most sense. If you run the command and then pick, then it will actually follow those things more or less explicitly. So, if I actually do the same thing, but I want the opening to be on that side, so that's why I selected it that way, right? Because it doesn't actually close all the way back. Still have to sort of maybe mess around with the curve alignment a little bit, right? Then I can control actually which side is open, right? Based off of like which sort of section curve I pick first to initiate the loft, right? All right, the last one. Straight sections with a loft. This is a sort of shortcut. The lofts don't actually only do the sort of soft, fabric style sort of thing. You can actually in the options specify, so I'll do the loft, or actually let's just do it the same way we did before. I'll try to get an angle. Let's just pre-select all these, right? Loft. Let's sort of fix that. Okay, so once you fixed it, instead of in the style, instead of normal, you go to straight sections here, and you can click on preview. And actually, this is what it does. It instead of doing this sort of saggy interpolation, it just turns the corner. Say okay. Okay. So this is what the sort of straight sections option of the loft does. And obviously you can loft between these two. So you can do one more loft in here. Whoops, curve and curve. Say okay. Right. Copy it over. Just to, whoops. Copy it over. Just to kind of show us the steps, right? Copy it over again. Join it and cap it. So this, you actually get something that's very similar to the other loft that goes in the other direction, right? Sometimes this actually comes in handy. Instead of, if you have like profile curves like this that you're trying to connect, the straight sections is actually a really quick way sometimes to get a very similar end result. All right, so that does it for part 2.